We're now going to be talking about accessing and modifying data in NumPy. So we're first going to talk about indexing, which is essentially accessing values from NumPy arrays. So indexing in NumPy is almost the same as it is in Python lists. So we have an array here with some sample elements from a uniform distribution. This array comprises of 4 batches with 30 elements within each batch, and these 30 elements can further be divided into 5 rows and 6 columns. So since indexing in NumPy arrays starts from 0, if we want to index the 3rd row, the 4th column of the second batch, we pass the following values in. The 1 here corresponds to the second batch, as 0 corresponds to the first one, and the 2 and the 3 map to the 3rd row and the 4th column, respectively. We're now going to talk about slicing, which is essentially accessing subsections of NumPy arrays based on indices. If we want to slice along a batch and return all the elements belonging to a particular batch number, this is what we would do. So this is essentially the same as doing n of 0. Now, if we want to segregate elements belonging to the first 3 rows, the first 4 columns, and belonging to the first batch, these are the indices that we would pass in. We can also slice along multiple batches. So this index pattern returns elements in the 4th row, the 5th column, across all batches. Now slicing can also be done at intervals, and the syntax for slicing at intervals is as follows, where we provide the start, the stop, and the step size, and these are all separated by colons. Now if we want to print all the elements belonging to alternate batches, such that the step size is 2, this is what we would pass in. Now, if we want elements belonging to alternate batches from rows 2 to 5 and columns starting from 1 with a step size of 2, these are the indices that we would pass in. Now, we can also modify NumPy arrays. So to copy a NumPy array, we use the function np.copy and specify the array which we want to copy as an input parameter. To modify single values, we can pass the index at which we want to modify the value, and this is where the value changes. Now this is a simple check operation to see whether the value at ncopy is the same as the value at n. So since we've changed it to 0.5 here, the value of this is going to be false, which indicates that the value has been updated in the ncopy array correctly. So we now move on to modifying multiple values in NumPy arrays. So here we're going to be looking at a small section of the data present in ncopy. So we know that these two sections are the same, and so our output is going to be all true. And before modifying the values, we just quickly make this check. And once we modify the values within the subsection to be all 5s, we see that once we run this check, we are going to get an output of false, which indicates that our values have been updated correctly in